Let me begin by saying I think you can make it tighter.
Anytime we send information from one computer to another, whether that's over the internet or even a simple wired connection like this, there's a lot involved to make sure that the information is received correctly. Depending on the network or connections involved, there are lots of different ways for errors to occur. And often the reliability of a network depends more on detecting and correcting these errors than avoiding them altogether. So over the next couple videos, we'll look at some mathematical tricks that we can use to detect and even correct errors. And I'll show you how some of that math can be done really elegantly in hardware with just a handful of logic gates. But before we get into any of that, in this video I want to figure out the bare minimum of what it takes to send data from one computer to another.
There's going to come a point where I'll tell you about the resistor
So what's the most basic thing we can do to transmit information
300
from one of
ohms.
these
It could be
Arduinos
the
and
right
receive it
ohm
correctly
limit
on the
to
other?
get the ground on the
Well, if we're going
coding.
to program one of these as a transmitter that's going to send some data,
That little symbol
program the
that
other as
brings
a
it back
receiver,
down to.
let's start by figuring out how the transmitter is going to work.
Here we go.
Well, one of the simplest receiver to know how
This
many
guy
bits
right
it's
here.
getting. So let's slow it down.
You're going back up,
So to make it
changing
easy
the
to
pins
adjust, I'll
over
define
in the
the
first
target
order
transmit
to the
rate here
type
in
out
bits per second.
after the
And
point,
just to
and
start
it
out,
runs through this, does
relatively
this,
slow,
comes
we'll
back
start with
around,
5
does
bits
the
per
loop.
second. And then we can use this transmit rate of 5 bits per second to add a delay right after we output the new data bit. So we'll do delay, and then
You would see
transmit
this
rate
at the
is
8
bits per
bit. You
second.
need
So
the correct
1,000 divided by transmit rate will be milliseconds per bit. And so in this case, since transmit rate is 5, so 5 D3 maybe?
This guy.
So our LED's hooked up
The
to
little
data
thing
pin
down here
D3
is
on the
this guy
Arduino.
right here.
And then I'll just hook the other end of the LED to ground with a current limiting resistor. I think this is 330 ohms, but anything that's a couple. And so in this case, since transmit rate is 5, so 5 bits per second, this will give us 1,000 divided by 5
Binary and wave
milliseconds.
functions.
So in other words, we're going to have a delay of 200 milliseconds between each bit that we output. And if you think about it, the receiver is going to need to know this transmit rate in order to have any hope of interpreting this signal it's doing.
You are here now.
And so now if we look at the scope, what we see is
none of these buttons equally like the other buttons we were talking about a second ago. And they give you all this to start with. Hello
2
world.
volts, 4 volts, and this is almost 5 volts here. And so it's just constantly here at 5 volts. And that makes sense, right? Because our LED is on, so we're outputting a high voltage here. So we're seeing 5 volts here. And then the way I've got this set up now is each of these divisions across is 500 milliseconds. So two squares across is going to be 1 second. And I can also do a single shot.
Make all kinds of EM noise if you didn't get that resistor right. The ones and zeros of this thing doing it this way.
So now if I reset the Arduino so it reruns that program and then outputs the data again.
This stuff after he does all that.
16 character by 2 line LCD. There's a bunch of different commands, and you can look up online how this works. But LCD set cursor will move manage libraries.
So we just got done with that. We were talking about this. He's over here now.
Make sure that's installed. So we've got that, and then we just go up to the top and we'll include that.
Just
and
do
then
those
I'll define
things.
the pins that we're using.
You have to start
so
over.
LCD,
See, again, that's
D4
like because you skip the step to make it this,
and then LCD
and then you make that hello world. You won't understand this. You couldn't understand this really. It's just I have to brute force each one of these things and look at it.
We do our transmit
back to hello world.
Just initialize the LCD. And so you just define this object, and then in the constructor, we're going to send in all of the pins that it uses. So
and it will.
pin,
but your
EN
limitations
pin,
understanding how to do that, Crash Bandicoot, with your wampum fruit. And that
so that'll initialize the LCD, and then that'll give us this LCD object that we can do things with. So we do begin, and then start by telling it how big the LCD is. When it outputs a 0, the LED should be off, and when it outputs a 1, we should see the LED on. So even if you don't have an oscilloscope, if you slow the clock down a bit, it should be fairly straightforward to match this up and just to verify that it's doing what we expect it to do.